This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Ever wondered how electricity and magnetism are secretly best buds? We're diving into Faraday's law today, a fundamental concept in electromagnetism.
It's all about how changing magnetic fields create electricity. Pretty cool stuff.
So, like magic?
Not quite magic, but almost. Think of it as a hidden connection between two forces of nature.
Sounds intriguing. Let's unravel this mystery. So what exactly is Faraday's law? Lay it on me.
Basically, if you change the magnetic field around a wire, you generate an electromotive force, or EMF, that's voltage.
Right. So moving a magnet near a wire creates electricity.
Exactly. The faster you move the magnet, the stronger the EMF.
I saw this simulation online. It shows a wire moving through a magnetic field. What's the point of that?
It visually demonstrates Faraday's law. You can see the EMF change as you alter the magnetic field or the wire's movement.
So it's like a virtual lab experiment.
Exactly. A hands-on way to understand a complex concept.
This simulation is from iwanttostudy.org, right? What else is on that site?
It's packed with interactive physics and other science resources, lots of simulations and learning materials.
Sounds like a treasure trove for students. The simulation credits Wolfgang Christian and Tanwei Chung. What about the license?
It's open source, meaning it's freely available for educational use. That's a big plus for accessibility.
I also saw this simulation on another site with a whole bunch of other interactive resources.
Yeah, that's a broader educational platform covering various subjects. It's a great example of how open educational resources are shared and used.
The site mentions learning goals. What are they trying to achieve with this simulation?
To help students understand Faraday's law, its applications, and the relationship between magnetic and electric fields. They also provide links to other resources like videos and research papers.
The site mentions improved versions of the simulation. What's the story there?
It shows how educational resources evolve and improve over time with contributions from multiple people. Collaboration is key, you know.
There's even code to embed the simulation into a web page. Pretty neat.
Makes it easy to integrate the simulation into online courses or educational websites.
They also mention translations and code. What's the significance of that?
It highlights the global reach of open educational resources and the importance of making them accessible to a wider audience.
The credits again mention Wolfgang Christian and Tanwei Xiang. What about the sample learning goals?
They provide a clear outline of what students should be able to do after using the simulation. It's a good way to set expectations.
There's a section specifically for teachers. What kind of information is there?
It provides background information and teaching suggestions, making it easier for educators to use the simulation effectively in their classrooms.
So Faraday's law, it's not just a dry scientific concept. It's a dynamic principle with real-world applications made accessible through innovative online resources.
Exactly. Open educational resources like these simulations are transforming how we learn science.
That was a great discussion. Thanks for sharing your insights.
Yeah.